In this lesson, we define a function. A function is a relation or a set of points in which every domain is assigned a unique range. In other words, each x is assigned one y value. We can also use for graphing a vertical line test where every vertical line that crosses the graph will do so once. In this problem, we determine if the given relation is a function. We observe that every domain value, every x, is mapped or assigned to just one y value. Therefore, this relation is a function. In this case, every domain value that we have listed here also is assigned just one y value. We observe that for the domain value of 3, the range value is 4, and for the domain value of 4, the range value is 4. This is still a function because each x value has only one y value. They may have the same value, but we do not have one x assigned two y's. Therefore, this is a function. In this example, we notice that for the domain value of 3, we have two range values, 0 and 4. Since this x value has two y values, this is not a function. In this case, we have every domain value with just one y value, in this case 1. Therefore, this is a function. We can even confirm it by using the mapping, and we notice that every x maps onto just one y. So this one is a function. For this graph, we can use the vertical line test, and we observe that this vertical line intersects the graph more than once. Therefore, this is not a function. For this graph, we observe, also drawing a vertical line test, that the vertical line intersects the graph more than one time in the location where x is equal to 0. We further observe that we have 0, 2, 0, -4. Therefore, this is not a function.
All right, you guys, let's talk about relations. What is a relation? A relation is simply a set of ordered pairs. All right, sometimes we're going to see like x coordinates and y coordinates when we have graphs, and sometimes we're actually going to see names like we could have Angie Starrett, math, Cassandra Jones, English, different situations, but at the end of the day, it's just a set of ordered pairs. All right, what is domain and range? You guys, domain is the input. All right, it's the set of all first components of the ordered pairs. Okay, so again, it's the set of all first components of the ordered pairs. And the range is going to be, obviously, since we're dealing with ordered pairs, the set of all second components. All right, we'll also be referring to range as the output. So again, domain, think of it as the input or the first component of the ordered pair. Range is the output or the second component of the ordered pair. All right, so let's look at this relation F. What's going to be the domain for this relation F? Well, I'm going to see, grab my pen here. All right, well, there's a first component, there's a first component, and there's a first component. And so 1, -2, and 3 is the domain for this relation. All right. Let's see here, what's going to be our range? Well, we have a 2, a 4, and a -1 as our second components. And so I have 2, 4, and -1 as I've circled in blue as my second components. All right, let's work on this one again. All right, so here we have relation G. Let's try to figure out the domain and range. All right, and so what are my domains? Well, I see I have a 1 there, a 1 there, a 1 there, and a 2. All right, so am I going to list 1, 1, 1, 2? No, I'm simply going to list 1 and then 2. These are my first components. All right, what about the range? Well, I have a 1, a 2, a 3, and a 3. And so what do I list? I list the 1, the 2, and the 3, even though 3 is repeated. And again, these are my second components. All right, what about here? All right, well, again, let me grab my pen. All right, what are my domains? And I can see that I'm using all of these numbers, right? 3, 2, 1, 0, -1, and 2. And so that's my domain, everything in that X circle. All right, those are my first components. All right, now where are the arrows going? The arrows are going to 10, 8, 6, 4, and 2. And that's my range, and or as we also call them, the second components. Okay, let's do another one. All right, what is the domain? Well, again, here I've listed domain. We use the 1, the 4, and the 2, so that is my domain. All right, and then the range is 2, 5, -5, and 0. Okay, so that is talking about domain and range for the relation.
Alright, what I want to do is show you guys how to find a functional relationship and to determine if you have a functional relationship between two sets, A and B. So our set A is just a set of letters and B is going to be a set of numbers. Now, to determine if it's a functional relationship, what they have is they have a set of ordered pairs. Now remember, one thing to remember with a set of ordered pairs is we have an input and we have an output. If you remember from my overview, we did our two sets, set A and set B. And remember, we had the input relationship to the output relationship. Now, there's a couple things to remember if it to determine if it was a functional relationship. First thing is everything in set A has to map to everything or something in set B. So first thing we look at is A map to something? Yes. Does B map to something? Yes. Does C map to something? Yes. Then the next thing that we needed to look out for to determine if it was a functional relationship was if everything that they mapped to was unique. And what we look over here is we notice that A maps to 1, which is unique. However, C maps to 2 and C maps to 3. So therefore, that is not a unique relationship because C maps to 2 different output values. So therefore, this is not a function. Over for letter B, again, we just go ahead and check, make sure everything in set A maps to everything in set B. So you see A maps to 1, B maps to 2, and C maps to 3. Then are those all unique relationships? And you can obviously see that yes, every single one of those is unique, so therefore this is a function. Then we get a little tricky with this one, and this is a function relationship, as you can see between just a set of ordered pairs. It is a function relationship. However, we're only asking, is this a relationship from set A to set B? And what we did is we actually switched the ordered pairs. So therefore, set A is now not the input variable. Set A is now the output variable, correct? So now this would actually not be a function. So just a quick reminder, you always have to have everything in set A as your input values. All goes to a unique value in your output values. You can have extra in the output values, and you can have the same input values or different input values go to the same output values, but you cannot. They all have to be a unique relationship. So that is how you determine if it's a function relationship.